Now we are going to do another example on partial fractions. Now notice that this is a proper fraction. So to continue, look at the factors here. This is a linear factor repeated twice, and this is an irreducible quadratic expression. So we have three partial fractions: x plus 3 in the denominator with a constant on top, x plus 3 squared in the denominator with a constant on top. Now this is the quadratic expression. So in the numerator we have a linear expression because it has to be 1 degree less. Now don't get confused about this expression. This is not considered quadratic, it's considered linear, that is repeated twice. Now I have added the three partial fractions using a common denominator, and now when I compare these two, I notice that the denominator is the same, so I can equate the numerator. Now I'm going to expand some of these so that it's easier for comparison. So we have x cubed plus 3x squared plus 3x plus 9. This one does not change. And here we have cx multiplied by x squared plus 6x plus 9 plus d multiplied by x squared plus 6x plus 9. So we first let x equal minus 3. X equals to minus 3 means on the left we get 9 plus 15, that's 24, equal. Now minus 3 means this will disappear and this term will disappear. So we are left with 9 plus 3, that's 12b. So we have b is 2. Next, to obtain a, c and d, we have to compare coefficients. So we start by comparing the constant terms first. So we have 15 on the left is equals to, this is 9a plus 3b. Here there are no constant terms, plus 9d. Next we compare the terms in x. So on the left there is no term in x. This is on the right, we have 3a and then plus 9c plus 6d. Next we compare the terms in x squared. So we get 1 on the left. This is equals to 3a plus b plus 6c plus d. Next we compare the x cubed terms. On the left there is no x cubed term. Here we have a plus c. Now you can try and do a solve for it, a, c and d here. Do this by yourself and you should get a is half, b we found was 2, c is minus half, and d is half. Okay, try this out yourself. So now we can integrate. So this is our question: x plus 3 squared, x squared plus 3 dx. Now we have half over x plus 3 plus 2 over x plus 3 squared plus minus half x plus half over x squared plus 3. Now as before, I like to factor out the constants and split everything up. So I have half 1 over x plus 3 dx plus 2 1 over x plus 3 squared. Then here minus half x over x squared plus 3 plus half 1 over x squared plus 3. So then we have half log x plus 3 plus, no, this will be a minus 2 over x plus 3. If you don't know how to do this, use a u substitution here. Minus 1 over 4 log x squared plus 3. Again, if you don't know how to do this, use a u substitution. And finally we have 1 over 2 root 3 tangent inverse of x over root 3 plus c.